Hey, Trig students, Mr. Meunier back here again today. Today we're going to go through section 7.3 with trigonometric identities. We have touched on trigonometric identities before. They are in essence formulas that help us simplify what could be complex trigonometric expressions, equations, functions. They're going to become more vital here in chapter 7. Today, we're going to go through a topic called verified trigonometric identities. So section 7.3 is about trigonometric identities, and really it's about verifying these things. And that's going to come down to the idea that we need to show that we have a true statement. Prove a statement is true. That's what we are doing today. We're going to prove a statement is true. Now, to do this, there's kind of some rules we need to go over. So let's get rid of this identity equality work. I'm going to put in a set of rules. First thing, every problem we do here, you're going to have a left side and a right side. And your goal is to make them match. Goal is to match left and right side. Goal is to match those things. Now to do that, we can never move a term from one side to the other side. And that's the biggest mistake people make. These verification problems are not solving equations. So we're not going to move things around. We need to alter things. So again, never move a term from one side to the other side. And to make these things work, since I can't move things from one side to another, we use identities or our formulas to replace terms or algebraic properties to manipulate terms. Use identities or formulas is another way of saying identities to replace terms or your algebraic properties to manipulate terms. Right. So what are these formulas? Well, some of them are written on our page here, but you also should have from your folder here in Schoology, or I handed you in class, this large identity sheet with a whole bunch of these things listed. This will always be provided to you. You never have to memorize this. You have to be aware of them, but you never need to memorize what these things are. And within these, I want to emphasize for us specifically the next few days, you are going to be using the reciprocals, the quotients, and the Pythagoreans. Do not dive into the sum difference double half angle formulas down below. We will get to those over the course of the next week. But all of these we will be using. You don't have to memorize them, but you need to be aware of them. And notice, like the Pythagoreans, sine squared plus cosine squared equals 1. But if you manipulate this sine squared plus cosine squared equals 1, you can get that sine squared equals 1 minus cosine squared if you subtract the cosine. Or if you subtract the sine, you can get cosine squared equals 1 minus sine squared. These get used a lot. I'm going to box these. They are used several times in a typical verification problem. All right, so always be aware of this. Keep this handy. Put this out next to you as you work through these things. All right, so these can be somewhat frustrating because I can't give you a set of directions that will work every single time. It's more of a trial and error process. So I'm going to give you some useful hints, tools that seem to work often. So for instance, this first one, A, is not quite what we want. Again, every one of these problems tangent theta over secant theta equals sine of theta. You should always have a left side and a right side. So this one's incomplete the way it's written. I will never give you just one side and kind of have you just blindly work it out. I know here I want to turn tangent over secant into a sine. Okay, so again, this is the problem we are dealing with. Add that on, and everything you do on a quiz, test, homework will always have a left side and a right side. You will never have a problem that's a one side. Now, here, we cannot multiply the secant across. Again, anything that's on the left side stays on the left side. Anything on the right side stays on the right side. Nothing goes from one to the other. So we have to use formulas to manipulate, or some algebraic properties like FOIL or factoring or canceling a fraction out to manipulate. I can't multiply or add from one to the other. And one useful hint that tends to work sometimes is rewrite things in terms of sine and cosine. So for instance, tangent is sine over cosine. If you look at your identity sheet, the quotients, tangent is sine over cosine, and then secant is 1 over cosine. So we can substitute each of those in. And that's what I'm going to do here. Instead of tangent, I'm going to put sine theta over cosine theta. And instead of secant, I'm going to put 1 over cosine theta. And this equals sine of theta. That's what it's going to equal, hopefully. Now, you have to overshow work. Don't assume anything here. So if I'm dividing with two fractions, I need to multiply by the reciprocal of that second fraction. So sine over cosine will be multiplied by cosine over 1. That still equals sine of theta. And then you need to finish this, because if we have cosine on top and bottom away from each other, they cancel out. We got a sine of theta equals a sine of theta. Make sure you write the last step. You need to get to this equality statement where sine equals sine. Okay, so that's one. Multiplying by sine and cosine can be a useful hint. Another one here, another idea that tends to happen somewhat frequently. We want to show that sine over 1 plus cosine equals 1 minus cosine over sine. Again, this is a normal problem because you have a left side and a right side. I want these to match. Whenever you see 1 plus or minus something, multiplying by its conjugate tends to work well. So I see that 1 plus cosine. I'm going to multiply the top and the bottom by 1 minus cosine. Okay? When I do that, things tend to work out in the denominator, the conjugate piece. So I'm going to have 1 times 1 is a 1, positive, because this is a FOIL problem now, I should have said. It's a FOIL problem. Positive cosine and negative cosine. Positive cosine outside, negative cosine inside cancels out. Minus cosine times plus cosine is minus cosine squared. Up top, I could distribute the sine in, but I don't really want to do that. Another useful hint is to keep the end of the problem in mind. We know what we want to get to. I know I want a 1 minus cosine on top. I have a 1 minus cosine here in red as the conjugate. I don't really want to distribute that and mess it up. So I'm just going to write sine of theta times 1 minus cosine theta and just kind of leave that for now. I would typically distribute, I just didn't because I know I want a 1 minus cosine in my final piece. So we're here. I got this 1 minus cosine squared on bottom, and that's where that identity sheet comes in handy, where I pointed out here in this middle piece where the little hand's going, 1 minus cosine squared is sine squared. Well, that's going to help us because I want a sine on bottom anyways. we get sine of theta times 1 minus cosine of theta over sine squared equal to 1 minus cosine theta over sine of theta. Now we're almost there because the sine theta hanging out by itself on top takes out one of the sine thetas on bottom. That gives you a 1 minus cosine over a single sine of theta. And there we go. Got it done. And this is kind of like a proof in geometry class. You know what the answer is going to be. You know that last part, we're given something. We always got to figure out how to make it happen in the middle. All righty, so moving on. Again, this next one is somewhat incomplete because we don't have what it's equal to. So I'll kind of give that to us here. If we have, put it in black, 1 over 1 minus sine of u plus 1 over 1 plus sine of u equals, should be 2 secant squared u. So again, we will always have a left and a right. Always, 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 always. And the useful hint here, notice the right side, our ultimate goal is one group, one term, one piece, but this left side has two separate fractions. So I need to somehow turn these two fractions into one piece. And to make that happen, you have to have a common denominator. You have to have a common denominator. So if 1 plus sine of u is the denominator on this right fraction, I need to multiply the left fraction by 1 plus sine of u on top and bottom. And if 1 minus sine of u is the denominator of the left side fraction, I need to multiply the right side fraction by 1 minus sine of u on top and bottom. That's going to give us 1 plus sine of u over this. I could FOIL that out, I guess. 1 plus sine u, 1 minus sine u, 1 plus sine u, 1 minus sine u on these. That's going to be a 1 minus sine outside plus sine inside cancels, and then minus sine squared u plus, on the right side, 1 times 1 minus sine of u is 1 minus sine u over, again, 1, and then plus sine minus sine cancels, minus sine squared of u equal to 2 secant squared u. It was nice that these were conjugates. It kind of killed two birds with one stone there, in that we got a common denominator and they are also conjugate pieces, which are useful for us. Let me fix that. That's pretty sloppy, even sloppy by my standards. Okay. So here, we do have a common denominator. So I can merge this into a single fraction of 1 minus sine squared u. Numerator, I have a 1 plus a 1, which is 2. Positive sign plus negative sign cancels out. Again, the positive sign plus the negative sign will cancel, while the 1 plus the 1 made a 2. So we're kind of getting closer. I have a 2 and a 2. Not quite there. I want to get to a secant. I don't know what's going to happen with that, but I do know, again, that 1 minus sine squared from your identity sheet, 1 minus sine squared is always cosine squared. So 2 over cosine squared equals 2 secant squared. I want secant, but I have a cosine. Cosine on bottom is good for us right now because 1 over cosine is secant. So 1 over cosine squared is secant squared, and 2 over cosine squared will be 2 secant squared. We've done it. And again, always write the last step. Okay. Well, let's do one more. I'm not going to do all the other ones on these notes. Again, same issue here. We do need a left side and a right side. So I'm going to give us that. 1 minus cosine squared v over sine v plus cosine v sine of v equal to, this should be a cosecant v minus a cotangent v. And you're always going to have a left and a right to work with. All right, so what to do here? Well, it's kind of the opposite of the last one. Last time I had two fractions wanting to turn into one thing. Now I have two pieces, but one fraction. I kind of need to separate this out. And factoring is a good way to separate things out. The numerator and denominator of this will factor. The denominator, you'll notice, sine plus cosine sine. Both of these pieces have a sine in common as a common factor. I can pull that out and get 1 plus cosine of v. The numerator is a little bit tougher to see sometimes. 1 minus cosine squared. That is the identity from before. That's a sine squared. I don't want to use that here, which is kind of frustrating because if I do, I would like to use it. It's somewhat frustrating that I can't. I can't use it because if I do, I'm going to kind of go in a circle. And I've done that before. It's not the end of the world, but you're going to realize about 2 steps later that that's not what we wanted to do. You're kind of going around and around and around. This, though, is powerful because it's an identity and it also factors. That's a difference of squares. This becomes 1 plus cosine of v and 1 minus cosine of v. And that really helps us out because now 1 plus cosine and 1 plus cosine will cancel. And we're left with a 1 minus cosine over a sine equal to a cosecant minus a cotangent. And this next step is somewhat common. It kind of throws people. It goes against what you've always done. This fraction has a one common denominator of sine. We can take that one denominator and split it apart. Kind of the opposite. Typically, you get a common denominator and merge it into one. Well, you can take one denominator and split it off into two, using the 1 and the cosine as the two different pieces, like so. 1 over sine minus cosine over sine equals cosecant minus cotangent. So again, this sine was a common denominator. You would normally put it back together and say 1 minus cosine is the numerator, but it also works the other way. And once we're here, we're pretty much done because if you look at your identity sheet, your formula sheet, 1 over sine is cosecant and cosine over sine is cotangent. Again, 1 over sine is a cosecant, cosine over sine is a cotangent. Cosecant v minus cotangent v equals cosecant v minus cotangent v. And we're good. All right, there's some more on here we're not going to work through. You have a worksheet for homework. Hope this goes all right. See you guys soon.